In this experiment, we are interfacing IR sensor, LED and buzzer with Nodemcu. This is the circuit diagram. Here I am connecting IR sensor to the Nodemcu. The VCC of IR sensor, it is connected to the VCC rail on the breadboard. That is the +1. And the ground of IR sensor, it is connected to ground pin on the breadboard. And the signal pin, out pin of IR sensor, it is connected to pin number 7. Here I have written pin number D7 of Nodemcu. And the LED anode, it is connected to pin number D8 of Nodemcu. And the LED ground, it is connected to ground rail on the breadboard. And the buzzer, positive buzzer, it is connected to D6 pin of Nodemcu. And the negative pin of buzzer, it is connected to ground rail on the breadboard. This is all about the connection. So you can refer here. And the out pin of sensor, it is connected to D7, LED to D8, anode to D8, and buzzer to D6. So after doing this connection, so we will declare one variable int because in order to read the sensor, I am using the variable x. In the setup function, we are using serial monitor. So for that purpose, serial.begin 9600 baud rate is used. And since IR sensor, it gives the value to the Nodemcu. So this pin acts as a input pin. So using pin mode, we should make it as an input pin, IR comma input. And LED is a output device. From Nodemcu, the signal goes to the LED. So LED comma output. And the buzzer is also output device. Using pin mode, we are making it as an output device. This is in the setup function. In while loop, we are reading the IR sensor value. Since the variable I have used as IR, so x is equal to digital read IR, reading this value and storing it in a variable x. And that value we want to print it in a serial monitor, serial.println x. Then some delay we will give, either 300 or 3000 delay you can give. Then we will check the sensor value. If sensor is, it is a, IR sensor is an active low signal sensor. Because whenever it senses the object or it gives the low signal. So whenever it is not sensed, whenever it is not activated, it gives high signal. So if it is equal to 1, it means sensor is not activated. So that time we'll make LED low and buzzer also off. Else, if x equal to 0 means the sensor is activated, we will send high to LED and high to buzzer to turn on the buzzer. So this is about the code explanation. We will write this code in a Arduino IDE software and upload it to the Nodemcu. So let us write the code in a Arduino IDE. In order to save the program, I have already written the same program what I explained. I have written in Arduino IDE software. After that, so you go to Tools, select the board under ESP8266 Nodemcu 1.0 12E model and select the port COM3. Then you upload the program. Okay, compiling is done and it takes few seconds to upload the program. Okay, uploading is done. Now we will check the output. Now when there is no object in serial monitor, it is showing 1. When I keep my finger or my hand near the IR sensor, it will show 0. 0. When there is motion, 0. When there is no motion, it shows 1. Here we are interfacing IR sensor, buzzer and LED. LED cathode is connected to ground terminal, and buzzer negative terminal is also connected to ground terminal here, and buzzer positive terminal is connected to D6 pin of Nodemcu, and LED anode is connected to D8 pin of Nodemcu, D8 pin of Nodemcu, and this is IR sensor. IR sensor output, it is connected to D7 pin of Nodemcu. IR sensor VCC is connected to VCC on the breadboard, and ground is connected to ground on the breadboard. This is about the connection. Now whenever the object is moved near the IR sensor, so the LED is on, the LED is turned on. So whenever the finger is moved near the IR sensor, LED is on and buzzer is also on. When I remove my hand, LED is off and buzzer is also off. That you can see it in a serial monitor. It is buzzing, it is showing 0 value. When there is no motion, it will show 1 value. When there is a motion, it shows 0 value. When there is no motion, it will show 1 value.